Hello everybody. Today we're going to be talking about AP Chemistry's topic 1.7, periodic trends. So before we get started on periodic trends, I want you to get in the frame of mind of Coulomb's law. And if you remember from Coulomb's law, the force between two charges is proportional, and we'll use the proportional symbol, to the charge 1 times charge 2 over the radius squared. In other words, more charge equals more force of attraction, and more distance equals less force of attraction, because distance is in the denominator, so as distance gets bigger, force gets smaller. So everything we're going to be talking about in this video is based on if there's more charge, there's going to be more force of attraction. If there's more distance, there's going to be less force of attraction. And then the other thing you really need to think about is what are these charges that are involved in an atom. And positive charges are always protons, negative charges are always electrons. And the more protons you have, the more positive charge you have attracting the individual electrons. Okay, and last but not least, remember protons are in the nucleus and electrons are in their orbitals in the electron cloud. Okay, so let's get started. There are three different trends that we're going to be talking about in this video in depth. One is ionization energy. And if you don't remember what ionization energy is the amount of energy it takes to remove an electron from an atom. So in order to remove an electron, you've got to pull it off of that attraction from the protons. So that takes energy. It's an endothermic process. So removing electrons from the protons is what we call ionization energy. You have first ionization energy, the energy to remove one electron. You have second ionization energy, the energy to remove a second electron. The third ionization energy, energy to remove a third electron, etc. The second trend we're going to be talking about is atomic radius. An atomic radius, for simplistic sakes, is just the distance from the nucleus to the outermost electron. So kind of like the radius of a circle is from the center of the circle to the edge of the circle, atomic radius of an atom is the distance from the nucleus to the outermost electron. And then last but not least, we have electronegativity. And if you don't remember what electronegativity is the attraction that an atom has for another electron. In other words, relative to other atoms, does an atom have a strong attraction for gaining an electron, becoming a anion? So those are the three that we're going to be talking about. And again, please think of these in terms of amount of charge and distance as we go through each one of these. Okay, so first let's talk about ionization energy. If you look at the periodic table, as you go across a period, each successive atom has a higher effective charge. And remember, effective charge, ZEF, is equal to the number of protons minus the core electrons. And so as you go across, the core electrons stay exactly the same. For instance, all of these elements in the second period have 2 core electrons because each one of these have their valence electrons in the second energy level. If you look at the third energy level, each one of these has 10 core electrons because they all have their valence electrons in the third energy level. So the core electron stays the same as you go across a period, but the number of protons increases as you go across a period. So this one has 11 protons, 12 protons, 13 protons, 14, 15, 16, 17, 18. So as you go across a period, there is a higher effective charge because there are more protons, but the same number of core electrons. And so what this means is there's more pull from the nucleus on those valence electrons. So sodium has an effective charge of 1, magnesium has an effective charge of 2, aluminum has an effective charge of 3, 4, 5, 6, 7, 8. And the higher the effective charge, the more charge there is, the stronger the force on the electrons. So if there's more force on the electrons, it's harder to remove the electrons. And so as you go across a period, the ionization energy increases because the effective charge increases. Now, when we think about first, second, and third ionization energies, let's think about that a little bit. Let's think about aluminum. To remove one electron from aluminum, you have to remove it from a p orbital. Once you remove that electron, then you're going to have one less electron. You're going to have 12 electrons. But you still have the same effective charge. You still have the same number of protons, and you still have the same number of core electrons. And so aluminum still has the same number or the same effective charge, pulling on the valence electrons. But now there's less valence electrons. So each of the valence electron is being pulled by the same number of protons, but now there's less electrons. So there's a stronger pull. So if we want to remove a second electron from aluminum, the next electron is going to have to receive a lot more energy to remove it, because it's still being pulled by the same number of protons. So the second ionization energy is going to be higher. The third ionization energy is going to be even higher, because once we remove the second electron, it's going to be even harder to remove the third electron. Now let's think about the fourth ionization energy for aluminum. For the fourth ionization energy, that electron is going to be on the second energy level, very, very close to the nucleus. Because it's going to be close to the nucleus, smaller distance from the nucleus, you're going to have a much larger force on that electron. You're going to have a massive jump right here between the third and fourth energy level. Between the third and fourth ionization energy, because once you've removed 3 electrons from aluminum, the fourth electron is from a lower energy level. And so there's less shielding, there's a much higher effective charge, and that fourth electron is going to be very hard to remove from aluminum. So with ionization energy, as you go across a period, the ionization energy increases. Each atom requires more energy because there's a higher effective charge. As you increase the number of electrons you remove from an atom, the energy required to remove it is much greater. And once you change an energy level, that electron is going to require a huge amount of energy in order to remove it compared to the other ones. So in the case of aluminum, we have a big jump between the third ionization energy and the fourth ionization energy. Because aluminum has 3 valence electrons, the fourth electron would be a core electron. Okay, last thing about ionization energy, as you go down a column, the electrons go in higher and higher energy levels, meaning that there's a greater distance between the nucleus and the valence electrons. And if you have a larger distance, according to Coulomb's law, there's going to be a much smaller force, meaning it is much easier to remove valence electrons from higher energy levels than from lower energy levels. So ionization energy decreases as you go down a column. Atomic radius. So the atomic radius trend is very similar to ionization energy, at least for reasons. As you go across a column, the effective charge increases. And as you have a greater effective charge, the electrons get pulled tighter and tighter to the nucleus. There's more force. So as you go across a period on the periodic table, the atomic radius decreases, because higher effective charge means more force of attraction. As you go down a column on the periodic table, as you go to higher energy levels, there's a larger distance between the nucleus and the electrons, and so there is a much smaller force, and the electrons are much farther away. And our last trend, electronegativity, is the attraction an atom has for an extra electron. So if you think about what we talked about already, as you go across a period on the periodic table, there is a higher effective charge, stronger force of attraction to the nucleus. And that means an extra electron is going to be more strongly attracted to atoms on the right side of the periodic table with a high effective charge than they are to the left side of the periodic table with a low effective charge. So as you go across, electronegativity increases due to higher effective charge. And as you go down, because the valence shell is a larger distance from the nucleus, there is going to be less electronegativity. There's going to be less attraction for an extra electron. So let's just apply this real quick and just think about if you can figure out the trends. Let's think about magnesium versus chlorine. Which one of these two elements is going to have a higher first ionization energy? The answer is chlorine. Chlorine is going to have a higher first ionization energy because it takes more energy to remove an electron from an atom with a high effective charge than an atom with a low effective charge. Which one of these will have the larger atomic radius? Well, magnesium will have the larger atomic radius because it has a lower effective charge and so less pull on the valence electrons, which means that they can be farther away from the nucleus. And last but not least, magnesium or chlorine, which one will have the higher electronegativity? And chlorine is the answer for that one, because electronegativity has to do with attraction for electrons. So higher effective charge on chlorine means there's a stronger attraction for adding an extra electron to its valence shell. Okay, so let's try another couple and just see if you can answer some more questions. Let's look at calcium versus selenium. Which one of these two will have the higher third ionization energy? Which one will have the higher third ionization energy? Well, if you look at it, when calcium removes 2 electrons, 1, 2, it's 2 valence electrons, the third valence electrons have to come from a lower energy level, which is much closer to the nucleus, meaning there's a much stronger force on it. So it's going to have a very high third ionization energy because that third electron comes from a lower energy level, which is a closer distance to the nucleus. Scandium, 1, 2, 3. Scandium has 3 electrons in this energy level here, the 4th energy level and the 3d orbital. But that means it has 3 electrons that are farther away from the nucleus than calcium's third electron. So 1, 2, 3, all 3 of those come from higher energy levels. So that means selenium is going to have a lower third ionization energy because its third electron is in the 4th energy level versus calcium's third electron, which is in the 3p orbital, a lower energy level, closer to the nucleus. Okay, that's where I'm going to stop on this one. If you have any questions, as always, please contact me. I'll be happy to help you out individually. Good luck.